Hello everyone, welcome. We are pleased to welcome all attendees and speakers to the International Roundtable with the objective to discussing workflow management and the reproducibility of experiments in data science. We'll have speakers from French, from US. We'll have speakers from French, from US. We'll have speakers from French. Is there some microphone? We'll have speakers from French. Is there some microphone? Speakers from French. Sorry, we have some echo. Sorry, we have some echo. Sorry, we have. Okay, is everything okay right now? Okay, is everything okay right now? Yeah.
Yes.
Okay, right now. Yeah. Right now. Yeah. Right now. Yeah. Right now.
Tá muito eco, realmente.
Certo. Eu vou dar uma olhada. 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 Certo. Rafael, espera um pouquinho, desativa a conexão com o YouTube. A gente, eu faço a apresentação para você. Yes. Yes. Okay. Is everything okay right now? Without echo? Yes? Rafael,
Yes,
we can start again, okay? Could we start again? Just tell me if the YouTube is on. We can start. Great. Thank you. So sorry for this trouble in the beginning of this round table session, but we are going to start again. Sorry for all for this trouble. But anyway, we are going to welcome everyone, especially the attendees and the speakers, to the International Roundtable with the objective to discussing workflow management and the reproducibility of experiments in data science. We'll have speakers from French, US, and Brazil. And you are going to have this event during the next 2 hours. This event is promoted by the Big Data Research Group at Polytechnic School at University of São Paulo, Brazil, the Data Science Center, C2D, from Escola Politécnica, supported by the Bank Itaú in Brazil, and the Belmont Parsec project. We can find more information about the Parsec project in parsec.org. Next slide, please. Yes, just a short introduction of the Parsec project. Most of the researchers that will be part of our speakers of the round table, they are from this Parsec project. And the Parsec project is a Belmont forum supported by different research agents from Brazil, from France, from Japan, and from United States. The Parsec project, the main objective of Parsec project is to build new tools for data sharing and reuse through the transnational investigation of the socioeconomic impacts of protected areas. The consortium leaders of this project is Nicolas Mouquet, David Mouliot from France, and Alison Spicht, and Shirley Stahl, that will be part of the speakers of this roundtable today. This project is divided in two strands. This strand related with synthesis science is discussing how you can support fair approach in this project, and the group of data science that are going to develop the experiments, data science experiments. Next slide, please. I'd like to tell you about the main messages of the event promoters and organizers. The Parsec project will have a next meeting, very huge meeting in the next year, in September 2022, that will be in São Paulo. And all participants, all attendees are invited to be with us next year. And the researchers that are interested to submit papers and posters, we are going to open soon. We are going to announce the papers and posters. And please follow us in our link in your user in the Twitter, and you have access more access and more information in our webpage, parsec.org. The another promoter of this event is Center of Data Science of Escola Politécnica, C2D. We have opportunities for master and undergrad scholarships, mainly in Brazil, but we are open for international to submit for this scholarship. And the main area is data science and in artificial intelligence. We are open for different subjects related with this subject. So please follow the link and you can see more information about this. And the data science and big data research group of the Polytechnic School, you have opportunities for postdoc, PhD, master, and undergrad researchers, and inter-institutional collaborations. We have more information in this link, wds.poly.usp.br. And the host organizations are the Polytechnic School of University of São Paulo. Polytechnic School is one of the oldest institutions in South America related with engineering. It was created in the century 20, the end of century 19, sorry. And there is 15 different undergrad courses, different grad courses that have so much opportunities for grad and undergrad programs. And the Department of Computer and Digital System Engineering of Polytechnic School. This department is responsible for undergrad course in computer engineering at Escola Politécnica, and the grad course related with computer engineering too in Brazil. Next slide, please. So, before you start talking about the schedule, we created a Slido link that the audience, in the YouTube audience, could ranking some questions or some topics that we can discuss during the roundtable. Please follow this link. This link will be open until the last speaker to talk. So you can follow this link and ranking which subject, with which question would you like to address during the roundtable. If you have some specific question, we can text in the message of YouTube. So you can put your question, specific question. We have moderators that will bring these questions for the speakers. So we have some speakers that will talk during our presentation today. So this is the agenda, and the agenda will start with the first presentation. The first presentation is an introduction over data science experiment in fair approach. And you are talking about some general problem of reproducibility in data science. These first speakers are Sheila Stahl. She is Senior Director and Data Leadership from American Geophysical Union, AGU. You can find more information about AGU in agu.org. This is in Brazilian, we don't know, this is in computer science community. Some people, they don't know this community, but this is one of the largest community of scientific and professional organization in the world. We have David Roman. David Roman, a research fellow at the National Institute for Agronomic Research, INRA, in France. And he is working on interoperability needs for phenotyping hybrid information system. He is part of the team of Parsec Project 2. So, Sheila and Romain, please could you start your presentation? Thank you so much.
Thank you, Pedro. I really appreciate the invitation to speak, and Roman David is going to take my message and connect it back to the FAIR data principles, which everyone listening should be aware of. So I'm bringing up my slides now. Pedro, just nod your head if you can see them okay?
Yes.
Yes,
Perfect.
great. Okay, fantastic. Thank you for that introduction. So AGU has well over 60,000 members, and including all of our authors, we're well over 100,000 worldwide. And the opportunity to participate in this Brazil Roundtable is quite an honor, and I do appreciate it. So I will talk about reproducibility very broadly and the general challenges, and provide you with some resources where you can look further. And starting here, Marcia Mcnutt is the president of the National Academies of Science in the United States. She holds a very prestigious role, and prior to her position there, while she was the editor-in-chief of Science, one of the highly respected journals, she wanted to take the challenge around reproducibility and team with a number of other folks to actually lift that up and ask journals to help with this. And she identifies that reproducibility, rigor, transparency, and independent verification are cornerstones of the scientific method. And though, and you can read here, even if a result is reproducible, that doesn't make it right. And if it's not reproducible, it doesn't make it wrong. But what's very important is that we do our best to be rigorous, to be transparent, so that it's clear to everyone what it is the intention is. And the DOI for her, for this, where she actually gave this quote, is provided. In 2019, not too long ago, the National Academies, where she's president, brought together hundreds of researchers, including an international component, to do a deep dive on reproducibility and replicability. And highlighted on the right-hand side are specific elements having to do with data, but they also highlighted the challenges in asking the broader scientific ecosystem to do better and move forward in addressing challenges around these two elements. In our talks today, we're going to talk primarily about reproducibility. And they went ahead and defined them. So some of you may have slightly different definitions, but I think it's good to share what they decided reproducibility and replicability are. And later in subsequent talks, these same definitions will be brought up along with some other context. So consistent results coming from the same input data, computational steps, methods, and code, and the conditions is that definition, also known as computational reproducibility. So reasons why this is difficult. So what those general problems are, and this is captured in that report, inadequate tracking of what you do. So the record keeping within the work that you do, that you don't have a reproducible workflow, that you're not being clear as to what those steps were, either in your reporting or in your publication. The digital artifacts around your work, the data, the software, the workflow itself, you can no longer get access to those. And then perhaps there were challenges about reproducing others' research because of not enough information. And I know some of our subsequent talks will talk about some of those challenges as well. And that the culture of research can be a barrier itself. And the fact that these talks are hosted today is to help change that culture and highlight the importance of being reproducible. And I thank Professor Pedro for this opportunity. There's a paper, now it's aged a little bit, it's from 2016, but it's still relevant today. And I want to highlight some of the authors here. Victoria Stodden, Professor Stodden has been on my advisory board for the work I do at AGU. She has led some of the work at the National Academies, and her publications around computational reproducibility are looked upon as some of the seminal work in that area. So she has been a guide for much of what I do. Marcia Mcnutt, we just saw that quote, president of the National Academies, was one of the co-authors. And highlighting one other author, Brooks Hansen is the executive director at science at AGU and my boss. So I was just connecting the dots between all of those co-authors. In this paper, they actually, they made some very salient points on recommending steps towards reproducibility. And here are those steps. And after I walk through these, I'm going to hand over the presentation to Ramon David to connect these steps to the work that we're doing in Parsec when it comes to FAIR data. So I am excited about his presentation. So first of all, sharing your data and software and workflows such that it's available for others to evaluate. Having persistent links. Persistent links allow those artifacts to be linked to your publication and linked to other identifiers such as your own. As a researcher, you should all have ORCIDs, for instance, and linking that content. And then enabling the ability for credit to happen, not only with your digital objects. So this is number 3, credit for your work, your data, your software, by linking that to your papers and publishing that separately. That should be a standard practice within the reference section and including citations. And then having enough documentation about those digital objects as also known as metadata, and Ramon will talk about this further, and then making the licensing in terms of use for those digital objects very clear. So certainly if you have any questions on this, I'm happy to answer them. And Roman, I'm going to stop sharing so that you can hop in now. Thank you so much.
Okay, you see my screen?
Yes.
Yes.
On full screen, it's okay? Okay. So just to take the 5 points of the Victoria Stodden paper, I would like to make a parallel with data sharing. And you know that the FAIR principles were published by Wilkinson in 2016. So it was the same year. So there are some parallels on some FAIR requirement to have reproducibility of workflow management and computing. So the first point, shared data software workflow and details of the computational environments are really linked to lots of, perhaps all the FAIR principles. You can see you have 15 principles and criteria, but some of them are strong and really critical. For findable, it's the F2 and F4 that needs to make data well described with rich metadata, and that metadata are registered and indexed in a searchable resource. For accessible of all the shared data and software, you need to have a standardized communication protocol, and to make them interoperable, you need to include qualifiable reference to other metadata. So linked all the digital objects that you can need in your computing process. And after the two last but not least are meta and data richly described with a plurality of accurate and relevant attributes that are community approved. And that's not a detail, because if you describe with some polysemic elements, it would make lots of problems. And so for the replicability, you need a detailed provenance. The second bullet, the persistent link, is in several Wilkinson criteria. So F1 that demands that metadata are assigned with a globally unique and persistent identifier. It should be the same for all the data objects. And the metadata must be clearly and explicitly include the identifier of the data they describe. For accessibility, you need this identifier to retrieve metadata and data. And for reusable, all your data and metadata are associated with this persistent link with detailed provenance. So we can see that there is a strong link in this second bullet too. We can consider too the interoperability with the criteria E3. Metadata and data include qualified reference to other metadata and data, and it's always the way via a persistent link. The fourth one, it's not really well linked to the FAIR principle, and I think that we can only consider the link with a global, unique, and persistent identifier. So to facilitate reuse, evidently data are described with rich metadata. For interoperability, we need community-approved vocabulary. So metadata and data use vocabularies that follow FAIR principles, and that's the case for all the digital objects. And for reusable, metadata are richly described with a plurality of accurate and relevant attributes. So the R1.3 data and metadata meet domain relevant community standards is critical. And for the last one, open license, it's more than that is required by the FAIR principle, because they only require a clear and accessible data usage license, and for reproducibility, it must be open. That's all for me.
Thank you, Shile. Thank you, Romain. So, following our schedule, you have next speakers. Next speakers are Gerard Subsol. He is senior researcher at the Laboratory of Computer Science, Robotics and Microelectronics, LIRD, located in University of Montpellier, France, and research of Parsec Pro 2. Marcia Mcnutt is associate professor in computer science at University of Montpellier and Nimes. He's French researcher at the Laboratory of Computer Science, Robotics and Microelectronics, LIRD, and he is part of the research team of Parsec. Laura Bert, she is research director in computer science, data engineering, data analytics, and machine learning in the Institute of Research for Development, IRD. This is the acronyms of this institute. From France, she is researcher from the team of Parsec Project 2. And finally, not the least, and Ali Ben Abs, he is postdoc of Parsec Project and at the Foundation for Research on Biodiversity, France. Please, Ali, go forward with your presentation. Thank you so much.
First of all, many thanks to you, Pedro, and all the team for the organization of the roundtable. Secondly, I thank my team in France for the collaboration to prepare this presentation. So my presentation today is entitled The Challenges in Reproducibility of Deep Learning Experiment, Presentation of an Example. So the aim of this presentation, I will present an example of reproducibility of deep learning based methodology. So from the Nature journal, more than 70% of research have tried and failed to reproduce another synthesis experiments, and more than half have failed to reproduce their own experiments. For the second point, from the Neural Information Processing Conference at the most famous machine learning conference in Canada, author willingly submitting code is quickly increasing from less than 50% in 2018 to nearly 75% in 2019. And also the number of participants in the reproducibility challenges continues to increase. And the last point is from the PLOS One journal, just 14.4% of participants had shared code data or both. So from this observation, you can conclude that the reproducibility is an important step to promote research. Starting by giving some definition as presented by Chile, the definition of reproducibility, replicability, and repeatability. That's the reproducibility is the ability to regenerate results using original data, software, and parameters. As you see, the same in the reproducibility, you use the same data and the same analysis to arrive the same results. The replicability is the ability to arrive at the same results using new data, different data, and some analysis. And the robust is the same data with different analysis. And last is the generalizable, that is the ability to run, that is to use different data with different analysis to arrive the same results. Here you present a level of reproducibility, that the reproducibility spectrum that define the relationship within the published material with the reproducibility degree. That, for example, here that if publication only is not reproducible, that if you have share the linked and executable code and data, you can see the gold standard of reproducibility. And the second one is the motivation now recently for the reproducible research, that more public data set are available and most methods and code are available from major conference and journal in computer science. And in order to having an open data science, a high pressure and workload on research to make their work reproducible. And that the reproducibility that have been applied in different fields. For our case, you present the reproducibility in the machine learning, but precisely the deep learning field. That the deep learning is defined as a branch of machine learning algorithm based on neural network composed of multiple layers extracted high-level feature from data set and used from the classification or regression task, as you saw in the picture here. There is an example for the classification of as input in image. So for the deep learning, as starting for original data set, some pre-processing techniques are necessary in order to improve the quality of the data set or to clean the data set. For example, you can make data augmentation, normalization of the input data. And the second part is the neural network model that describes the structure of the used model. And for the dataset, you split the dataset into three splits. The training data will be used in the training processes, and the test dataset will be used in the test and evaluation step. But for the training, you need to define some hyperparameters. For example, the loss, the optimizer, and the number of layer, and there is several hyperparameters to define, and it depends of the applications and of the field of what you have. So in the literature for computer science view, there are several initiatives in the literature to propose a checklist for machine learning reproducibility. Here you present a checklist that have been proposed in 2019 in the Neural Information Processing System Conference in Canada. This checklist consists on 4 parts: the dataset, algorithm, and the code and experimental results. From the dataset, there are some questions to check the data collection process, detailed description, processing steps, and the technique of splitting the split of the data, the training, how split the training, the data set into different splits, and the length of the long version of the data set. For the algorithm is the description, the parameters and the assumptions, and the analysis, the complexity of the algorithm, and the code is to define the environment that you can use it to reproduce this experimentation with the link of source code of the type and the description. And the last part is concerning hyperparameters of the used machine learning or deep learning method. So, as presented in the start of the roundtable by Pedro, the Parsec project and the context. The main propose in this our project is to propose deep learning based methodology to predict the wealth index or the poverty index using satellite images. So in in April 2020, there are a new paper have been published by Yi and al. Using publicly available satellite imagery and deep learning to understand economic well-being in Africa. So the main proposal of this approach is to propose a deep learning-based methodology to estimate, to predict the wealth index for 23 countries in Africa with good performance. And also there are a link of code for the code in GitHub link. So as I said, the aim of the proposed methodology for estimate with index using multispectral Landsat and nightlight images using deep learning. As I said, also the in the paper high prediction accuracy of 70% of the level at the village level and over 18% in discrete level. And the originality of this paper is to use a very large amount of data, image or surveys across different periods and many countries, 23 countries in Africa. So you can consider this paper as a reference paper on this topic. For this reason, you think to reproduce all the experimentation proposed in this paper. Here there are the link of the GitHub of in the team of the author of the paper. There are 3 contributors in the GitHub. There are and they have published all described for the all steps. So here I present the flow chart of the proposed methodology. So starting by the wealth index from the DHS demographic and health service dataset, and the first step is to calculate the wealth index, and from the location. From the location for each village for the wealth index, the first step is the download satellite images from the Google Earth engine. So you download the Landsat with 7 bands, and here the night light satellite image. The second step is to propose the satellite image that aims to split the download image for each village, for each country for 1 year. And the third step is to prepare the data files that aims to split the data in train and validation and test split. So the step 4 and the step 5 have the main purpose to estimate the wealth index within the 4 using baseline machine learning method such as CNN, and the 4 using a CNN based on ResNet training model. And the step 6 is to extract the learned future representation from the saved training model in the step 5, and finally during the regression between futures and indicator. And now I will present each step and the aim of each step and the difficulties that you have to reproduce it. But after that, the Yi and all have presented all information about hardware and software exigences to to reproduce their experiment, some information about the operating system, the RAM, the disk storage, the GPU, and some other package to install to reproduce this methodology. About and other information about other software about for the GPU, so that in this description you can see a complete description of hardware and software exigencies has been presented by the author. So now I will I present each step. So for the first step is the aim is to download all satellite images from a wealth index file. In this file, from the latitude, from the geographic coordinates, from that latitude and the longitude, you download all the image for 20,000 village into 23 country in Africa. The image, as you see in the left, the images are saved in zipped TF record format. With this format, country, year, and here the number of the chunk is a parameter. And with the TF record files, here there is some information about the storage and the expected export type from the data, from the two data sets used in the paper. So there are parameter chunk size parameter. This parameter is used to define the number of satellite image for each record. For each record, here is the chunk size define the number of satellite image. But the author have used this this parameter equals noun. That's now that will download all image for all for one country by year. So if you have a problem, for example, for one village, you can lose all the images for all for one country. So in this you have reproduced this step, but you can notice that in this step is a description of some parameters. For example, here the chunk size is missing, and also the original data for DHS are not available. Here, for this point, for the reproducibility, we didn't have problem. You can reproduce this experiment using the wealth index, but in the case of generalizable this methodology, we can do. You can do it because we didn't have access for the DHS survey. So here for the first step. Second, now the second step is to process the satellite image. This step aims to split the image saved in the first step. For example, here you are the name of country, year, and the number of chunk. The aim is to split each TF record by village, by country, by year. But with the second split, with the second script, you have show another format of the data. For example, in the last exactly gap between the two steps. The step one, according to single country, by year, with using TF record file. But in this step, you have found another format of the data, and here you have spent a lot of time to find the solution to solve this problem, but you didn't have any solution. So you have failed to reproduce this step, and now exact parameters value setting, and this description of the processor is missing. But after time, you have found another link of GitHub published in by the first author here, another second GitHub link that you proposed the same step of the proposed methodology, but in the second GitHub several steps are missing, generally the step of the training and the extraction of a feature representation and the training. So with the second GitHub, no update for the second link, and description of the experiment is missing. So coming back, so now for the second step, first of all, you verify that the aims to verify that the TF record match the original CSV file of the wealth index, and secondly, to split, as you saw in the right, to split each TF record into one file by record, and its file record represent a village by year, by country. And you have successfully reproduced this approach. As you see here in the left is the number of images of the village by country. The total number is 20,000 village, and here you present an example for the Landsat band. Here the RGB is a combination by the red, green, blue band, and here the other four bands of Landsat, and the last is a night light from the VIIRS sensor. Good, you have successfully reproduced, and that units that complete description of this step using the second GitHub link. So for the third step is to provide the data file that aims to split the data into training, validation, test data. So the aim is to assign the clusters into training, validation, and test split. In the paper, author have been used the two configuration in order to avoid the overlap problem or the overlap of the satellite image. For this problem, the author have been using two configurations. The first configuration is the out of country that aims to assign onto country to a split, and the second configuration is in a country that aims to assign different cluster with the same country to different split. And here you present the result that you have reproduced. Here that the split of using the first configuration here is the classification of each village in 5 folds, and here the same for the second configuration. So as the second step, a complete description, and you have successfully reproduced this step. So for the four that aims to design baseline machine learning methods to estimate the wealth index, for example, using KNN, and you have reproduced this approach, and you have found the same performance metrics as published in the paper of year for the two configuration for the DHS out of country and the DHS in of country. Really, you have successfully reproduced, but the description of this step is missing, and insufficient description of the parameter of this step of the defined parameter. But finally, you have found the same performance metrics as presented in the paper. So for the conversional neural network method in the paper, author have been used the ResNet network, the pre-trained network ResNet 18. for as presented, there are two configurations, and for each configuration, there is some hyperparameters. For example, the author have been used ResNet for the Landsat band, and another Landsat, another ResNet for the Nightlight band. And after that, you combine the two ResNet to predict the wealth index. And for example, there is some hyperparameters for each configuration. For example, here for out of country, the max epoch is 2000 for out of country, and 115 for the in of country, and other some parameters. Hyperparameters have been defined for this, and here you present the script of the training, the hashes with some an example that this example have been presented by Yi all. And in this step, you have reproduced the training, and you have trained using for the both configurations, and we noted that the exact parameter value setting and the description and some parameters that are missing. So for this step, the extract learned feature representation is aims to extract the learned feature representation from the saved training model in the last in the step in the step 5, but you have a gap that the same problem as the problem as I presented in the second step, the gap between the training script and the extract feature. For the training, you have used you have to use the name of experiment with the name of the hashes and the fault, and for the extraction, for the future extraction representation, we have used another configuration that is a problem the matching or between the two scripts, and as exact parameters, value setting, and description of the experiment and the parameters are missing for this step. So, as a conclusion for the reproducibility in this approach, you have still working on to reproduce, and you have finished to reproduce the first 5 steps, and now you are working. You have still working on this step on the extract learned feature representation, and the last step. So here from computer science view, from the experience that I have presented, and the difficulties that we have to reproduce this from this experimentation, that the description of the experiment are insufficient, that the hashes survey not publicly available. Not all figure and table reproduced, missing the readme file, the coding style also, and as presented in the second step and the 5 step, no exact parameters value setting, no update from the second script, but we have worked on 2 script. The first link we published with the paper, and the second code published by the first author, and you have tried to contact the author. No response for the author. So in the beginning of this presentation, I have presented this checklist, and the checklist have been proposed from the Neural Information Processing System Conference in Canada in 2019. So the aim of our aim is based on our experience, how we can propose an adaptive checklist or update or propose checklist for some fields. For example, in this case, you have used the satellite image with deep learning. So you have tried to For example, to update this checklist, for example, by added another part for the general presentation of the code. For example, you must use unique repository site, detailed documentation, and up-to-date information. How to make this update, for example, and to see, and also to possibility to discuss with the author, and also you can propose it some other idea for each part. For example, there is a problem, the data license and the original data and the pre-processing method. For the algorithm, the standard coding style, you can unify the coding style and the code license. For example, for our case, that we will use this approach. How you have license to reproduce, to publish this experiments of a year or now. You haven't this information, and the detail about the code and the script dependency, the matching between the script and matching between the file and all the step, and some information, for example, last initialization procedure for the deep learning methods. Thank you for your attention.
Thank you so much, Chad. Ali, please could you your microphone?
Okay, Pedro. Okay.
Thank you so much. So thank you so much, Ali, for this very good presentation. Thank you to Laurie, Mark, and Gerard to help for work with you during the preparation of this presentation. Thank you so much. So the next speaker will be I am Jeanette. Just a first introduction of me. My name is Pedro Luis Pizzigato Correa. I am an associate professor at the Department of Computer Engineering and Digital Systems at the Polytechnic School of University of São Paulo. And Janete Machical, she is postdoc at the Parsec project from Polytechnic School of University of São Paulo. Thank you so much. Janete, please go ahead with your presentation. Thank you.
Okay, thank you. Let's see. Okay, thank you everybody, and good afternoon. And thanks again for this invitation. And I'm going to talk about my personal experience, my professional experience on reproducibility of paper experiments. So for the project we are working on the Parsec project, the main hypothesis is to answer to if there is some influences of human well-being by using prediction inferences of socioeconomic indicators by using imagery. It could be data, satellite data imagery, or for instance, in street view images. So that's the main idea we have been working on. So, but the first thing to think about is to learn how to do this kind of projects, how to work on, how to learn the know-how to make the next steps. So to make some, to be a paper or experiment reproducible, once we have to start by reproducing us by self. So as Shirley pointed out, and also Ali pointed out about the technical definition of replicability and reproducibility, I myself have also some confusing these both terms, which is very important to see which are the differences. So for our cases, reproducibility is when some other researcher is trying to analyze on the same data or artifacts, software, or code from other paper and try to reproduce the same result as the paper original make it. So how to start? The first question is to answer if there is the paper is interested, so go to check if there is data available. And the second thing that these two things that I am talking about is about if there is data available or if there source code available. So just a minute here. We started by recognizing which are the state of the art on this problem by checking papers from deep learning and poverty prediction. These 4 papers were from the top main sources. Most of them are very recently, and they are based on satellite images as well as street view images, and all of them trying to make predictions from this imagery and trying to understand the better poverty or socioeconomic indicators, this kind of indicators similar. I'm going to put this. So, the main common methodology from all of them, it's by trying to making models. For instance, this one is which is the input imagery data set. Maybe could be an intermediate model where there is, in this case, the deep learning model that is able to train the imagery data sets, or if there is going to be a transfer learning from other data set. And finally, the output, which in these cases are the indicators that we are trying to predict. So, but from these main papers that I showed you before, not all of them has source code available, neither data. So for instance, the paper from Scientific Reports, if this one has a GitHub repository, as well as the work from Jean, the work from the Science, which also has a repo on GitHub. And the other 2 ones I have contact by email from this one from Ayush, and the author gently tried to respond me by just checking which are the steps to conduct the experiment. That was it. I couldn't get access to not source code, neither data. So as I mentioned before, this presentation is going to focus on the data challenges and the source code challenges. So from my experience, I noticed that one of the main issues with data is when data is dynamic. And for instance, we are trying with street view images or satellite images, which are very dynamic data, which change a long time. They are captured a long time. They are not periodic as well. They can be taken from month to month or from year to year. And even some gaps could be attached to this data, some clouds, or any other gaps that could be on this data. And of course, we would like to have the data that more static as we make want. And by static, I mean that the data is defined, they have no error, it is cleaned up already, and it's not more changes on the data. But as I say, the data is very dynamic, and they are continuously adding new stuff to the data. And some current approaches are trying to, the most easy to do is just by saying which is the date of access of this data. So steps on the, for instance, if we want to publish some other data or we want to reproduce from the other one, we must correct it specifically to mention which is the date was captured this data. Other approach is by using artificial versions or just to get the most similar or the most alternative versions from the data that is being trying to be reproduced. And the other challenge on data is about this granularity. Since we have been working with big data, there is databases with this enormous quantities of data. As of course, these are, most of them are timestamps or time series data. And so many researchers are trying to use just specific subsets of this data. There is a problem to how to identify which is the data set, the subset that I have been working on. For instance, by myself, with the data from Street View image captured from Google Street View, we have this problem where how to handle with the data set that I'm thinking on. So for instance, we are just capturing a subset of data. It's impossible to have the whole Google data set, but we capture just a year of data set from a Street View images from a limited geopolitical region. And we have to cite this area or make available this data set and all the description of metadata for this subset of data set. And of course, by storing a record of these data sets or making a DOI from them, that's the main thing we can do. Other data challenges what we have faced on are if the paper says that there is public available data and they make available, but there is not truly availability. Sometimes they provide it upon request, so we have to mail the authors and ask if they could allow us by some formally request by institutions or governments or whatever. And also there is this issue when some papers have data that is not more available, but they put it on paid sources, like for instance, the Planet service, which provides satellite image with very high resolution, but they are paid sources. So this difficults the research from others. Other challenges about the data sensitivity when there is the private data or data that could not, that contains privacy data set from humans or other kind of stuff. That is an open question to how to handle with this kind of data. And finally, about the data quality, when the paper doesn't, there is a lack of information to how to process this data. We have faced this problem with census data, where institutions like in Brazil, the IBGE, which is the institutional statistical data sets, the census data, they are public, yes, but they are very difficult to assess, and there is a high curve of learning to how to handle with this data. And this is also a very difficult for many researchers that want to just apply their stuff with this census data. And the second point that was talking before that was that only data, and the second point is about the source code reproducibility challenge. And what I see is that, okay, more papers, especially on computer science, are more prompt to share their code. Okay, that's a good stuff. But most of these papers, like this paper reported that from 1,050 500 researchers published their code, but 70% of their code are lacked to be reproducible because of third-party experiments. So all the other more than 50% that they cannot reproduce at all their own experiments from them. Other paper that also pointed out this challenge is on Pimentel, a recent paper as well. He collected almost 1.5 million Jupyter notebooks from GitHub, just to check how they, if they can be reproduced just by running as it is, the code. And from the 100%, only 4% obtaining the same results as it is stated on the GitHub, on the Jupyter notebook. And from the rest, 50% of them has results where almost half of the Jupyter notebook on the RC have the same results as it is stated. So there is many difficulties that we can face on our own code or on the code that it is being published already. So there is many other source code challenges and the ways we can handle and the ways that we have learned to be facing on, and maybe the ways that we recommend to improve to continue it on with the open science. So the first of all is the difficulty to compile source codes, most of them because of dependencies or deprecated functions. It happens a lot with Python because it's increasing, the growing of version is increasing speedily, and or some of the precompiled libraries doesn't work anymore, it's outdated. Some of their codes, they are lack from versions. For instance, on Python, they are changing from version to version, and the source code from Python 2.7 to the Python 3 has also been changed of paradigms. Very deprecated functions has not been running in the other one. So there is this kind of stuff. Some other source code also lack from instructions to how to run their own code. And also they are, some source codes are not available completely. Maybe just they publish their own, the most important part of a paper, but they lack of the pre-processing or the post-processing from a paper, or maybe that the plots that are made are not corresponding to the parts of the code that are supposed to be. So, but some recommendations to face these kind of problems is by ourselves doing our own reproducible papers from what we have already. For instance, by documented well our codes, to make it, as Ali also showed on their examples on GitHub, to make a README, a very well documented README, or a run all makefile script to see the workflow of the scripts and which script goes first and what goes second and so on. Very informative directory where we can structure the better how is the workflow of the data. And of course, if we are available to do so by showing maybe an example of how to run the code is, or provide the parameters, or how examples of how the command line is going to be. And also I saw that many papers are also making available their trained models. As in deep learning, there are many papers that are huge, where the trained model should be running on weeks or many hours on computer running. So they make available trained models so that anyone can start it from the trained model and go to the next steps. Also very important is to take care about the libraries that we are using ourselves, the libraries that are changing or evolving fastly. For instance, it's very common in deep learning libraries like TensorFlow, PyTorch, and Caffe, where they are changing. For instance, PyTorch has changes their syntax a lot in these past few years. And some of them Caffe is not being maintained anymore. For instance, the last commit was in 2019, which is a lot for in computer science, 2 years. Also, Python 2.7 is not being maintained anymore recently, in 2020. And in deep learning also, as we require many days to training a data, so they are many papers that are also making available their pre-trained models, and with the training routines that are making available this trained model. And when possible, we should avoid libraries or huge libraries that have many numbers of dependencies that are not so important. For instance, not to use a package that is huge, but just to be used for opening a file, and never more it's going to be used. So maybe just to try to avoid that, so that we can make reproducible experiments. And finally, I'm going to talk just about the do's and the don'ts that myself I have been facing about how to publish, how to not publish, also how not to publish, some mistakes to be passing on about the reproducible papers. The first of all, it's to avoid this kind of citations in inconsistent ways. This is my paper myself that I didn't found ways to make I didn't have a DOI from some of the data set that I use, but I used any consistent way to cite all of these. For instance, I have used source code from different sources, but they are not on the same way, and they are not trustable as well. Something that we can do is that about software versioning, we can do versioning whenever we possible to do, and also to keep energy, because when we have to go for the publishing and round revisions with the journal, we have to record ourselves how the code was done, or oh my god, I forgot what this part of the code does. And so keep energy until the end, just by using kind of versioning, so that you could see wherever you documented already. Other stuff that is making reproducible papers, it's about the good coding practices. So to for instance, document well your document by avoiding some bad practices on ifs and else to make more cleanable and readable code. It's not easy, but it's something that on that time we are going to be glad to be baked on the first beginning. About the software, we should not only cite the software that we are being using, but also to acknowledge that it has been used during our research, so that anybody could follow this behavior, and the culture has been changing so that everyone can follow on the open science flow. Other stuff is not to do, it's to avoid notebooks bad practices, for instance, but making our source code is running okay, but the cells from for instance, a Jupyter notebook is not on order, so that we cannot run one another, and the positions from them are not well. So, and to test our 2 round tests of our own codes, or if any other colleague is able to rerun their code, that will be great. About the metadata of the own software for reproducibility, and to publish also the configurations, for instance, on the environment from the we can use, besides the environment setups, we can use the Docker file or virtual machine environment with the full software with the operational system to carry on the software that we have worked on. Finally, just to focus also on what, for instance, in our case, on the undergraduate students, by helping them to construct their careers in following these recommendations, and so that they could also follow these recommendations and go on with the open science, the more reproducible papers in good manners. So, for instance, in the Parsec project, we have also worked on helping these students. On this year, on last year, we conducted many meetings, by virtual meetings, and we tried to instruct them and to help them with how to reproduce papers, and they have also reproduced, not only reproduced, but they have replicated other experiments based on on papers that have already been published. And that's it for me. Thank you, everyone.
Thanks, Jeanette. Thank you so much. Now you are going to the next section. The next section is about the discussion, some specific topic related with reproducibility and workflow with data science experiments. This section will be conducted by Professor Jorge Hadi. Jorge Hadi is he is Associate Professor of the Polytechnic School of University of São Paulo, Department of Computer Engineering and Digital Systems. We are going to stop this Slido right now, and we have some ranking of questions, and Professor Jorge Hadi, please go forward with the session of discussion with the speakers of the round table. Thank you.
Okay, Pedro, thank you. As Professor Pedro said, we have a ranking, and we have some questions that all the viewers made. Well, I think I will make The same question for the three groups of speakers. I think it's it's better. The champion of the ranking is this question: where can I find more material on best practices and reproducibility in general for computational research, or special for data science experiments? So I would that Shelley or Roman could respond to this question.
Thank you. And I think that for each of our talks, we all referenced some very good materials. And Professor Pedro, before you turn your camera off, may I suggest that we list those on the project website, and also in the Zenodo repository for the speakers' presentations, and then everyone will have access to all those materials.
Okay.
Roman, does that seem like would you want to add any more?
Yes, just to some observations that this all presentation will be available in the site of the Roundtable. All PDF will be available there, and the recorded video will be available there. So when you finish the event, we will send the email for all participants with all materials. Thank you, Shirley.
Okay, Jared, Mark, Laurie, Ali, please.
Yes, I think it's a good idea also to gather all our documents because we have some documents about more oriented on data, how to reproduce data or how to reproduce data processing. We have more document about deep learning experiments, and it's not exactly the same topics, because, for example, in deep learning, we have specific topics for reproducibility. So it is very interesting to gather all these documents in one site, because otherwise it's sometimes very difficult to find documents, because you are looking in your own field of research. And if you are analyzing another field of research, it's not exactly the same practice.
Okay. Janet and Pedro, do you have any more?
No.
Okay.
Just to point out that the works from Victoria Stodden are a very good material about computer science experiments, and this also references on Shelley work.
Okay.
I'll be sure to include her full website so that you can get all her work.
Okay. Well, I like the last question. I will change the order about metrics. Are there metrics to be considered in reproducibility in computational research? I consider very interesting this question.
I'd like to take a stab at that if you don't mind. I think it's really important to remember that being fully reproducible is difficult. And you've seen from Ali's presentation and Jeanette's presentation that they've run into a number of problems when they were trying to reproduce experiments. And if you consider a concept of good and better and best, such that you can evolve your own research to adopt more and more of what came through on recommendations, that's a really good way to think about moving towards being prepared for fully reproducible. We may never get there. We may be mostly reproducible, there were some comments from some of the other questions about data that's not open, software that's not open. And there are plenty of reasons for that. There's laws and protections that are in place for that. And you just do the best you can with what is possible. And then the next time you do better than that. So I think that's a good way of thinking about it.
Okay, thank you. Jared, Mark,
May I
Roy,
react about the metrics?
Okay.
I think that it's like it's the same difficulty, or perhaps more, than the metrics in the FAIR principles. We tried during 2 years to construct, to build together metrics in the FAIR data maturity model. There were 52 metrics at the end, and it was not adapted to all communities. So I think that if we have metrics, they must be community approved or community transformed, just because the needs and the complexity are not the same across disciplinaries.
Okay, thank you. Jared, Mark, do you have any?
I think that a good metric for researchers is the number of papers which use, in fact, your software or your data. So if they are able to reproduce your results, for example, to work with these results or to compare with their results, this is a good point. So for us researchers, I think this is the main indicator at the moment, of course.
And I would like to add that we managed to have some qualitative code quality metrics in computer science. So I'm very confident that at some point we will reach the state where we will have, reproducibility metrics, well documented, well tested, clarity, all of these are already existing in the computer science community for programming. So I'm sure that, of course, it's difficult. Of course, it may be multidisciplinary, which had more complexity, but we will get there. We will have metrics, and we will be able to quantify the reproducibility of the code. So I'm optimistic.
Yeah.
Okay, thank you.
Another solution that is used by many disciplines, many array of machine learning, and especially deep learning, is to organize competition. And especially I'm thinking about Kaggle competition, because thanks to this kind of competition, even if you don't have access to the code, and even if all the team around the world do not have access to the code, they can test and evaluate on the same with the same protocol and with the same database. And thanks to Kaggle, you can really better understand your topic, even if you don't have all the reproducibility and so on. So this is a good point, and I know that people working on few topics try to organize this competition just to better understand and to have a benchmark indeed at the end.
And also
Okay.
there is, this website, Paper with Code, that is, I think, very useful. You can have a look, depending on your topic, on your research interest. You will get papers and codes, not all of them, but and many codes sometimes when it's trendy. So it's good to have a look at the Paper with Code website.
Especially on this website, you can have some benchmark with some nice curve showing for each paper what is the accuracy on a given benchmark, and you have different benchmark and different database, and for each database you have different paper which are evaluated, and you can see on the curve what are the score for each paper. So it's really interesting.
Okay, thank you. Janet, do you have any comment?
Yeah. I also saw that on ACM papers, they are also putting some like a badge, a label that is saying this software is available, that this software is reproducible, and they gain these kind of awards in their papers so that they can make more citations. So the more they publish the full code and the most data available, the most the paper, the author gain as citations as well.
Okay. Well, we have a question made by some people of the YouTube. How to spur reproducibility if you use closed source data or software? I think it's interesting.
I can try that one. I can try that one. This is actually rather common in the Earth and Space Environmental Sciences. You know, think about all of the meteorological models that are proprietary, and there are a number of publishers on that, and then data sets that are coming from commercial space, commercial entities. And really, there's a couple angles here. As a researcher, you want to try to secure the opportunity to share that data and that model prior to agreeing to do research with closed software and closed data. That's not always possible. So what we ask our researchers and our authors to do is to be as descriptive as they can. For instance, if they can't release the software or the model, their paper still needs to be evaluated for its findings. And sometimes it's good enough to have some pseudocode that can describe how that software model works. And that's okay within that domain. That's an accepted practice within that particular domain. You'll have to ask the specific editor of the journal if that is satisfactory. Not all journals will allow that, but that is one option. And data that is protected, and Roman can actually comment on this as well, not all data is allowed to be open for lots of protective reasons, personal identification, laws and such, but it can be well documented and it can be cited. So you can, in fact, discuss where the data is in your availability statement when you choose to publish, and explain how another researcher can gain access. So that may be going through an IRB. It might be a specific, we don't recommend a personal contact because time changes, but an entity that's responsible for that data could be contacted and the method of access would be provided. It is critical for peer review that that data be available. So there needs to be a workaround for that.
Yes, perhaps a little add. May I can make an add to the Chile remarks. I'm working now in ERINA, you know, it's a European Research Infrastructure on highly pathogenic agents. So the data are not open. It's not possible. But we have to interoperate all our data, all our process, on all our computing processes. So that means that we need tools to be comparable between BSL4, it's highly contained laboratory, between us. So I think that the problem is the same, and I like very much the idea of competitions to reproduce experiences and results, because it can be done in a closed environment.
Okay. The second group of speakers have a comment.
Yes, I have a comment about effectively closed software or closed database, because sometimes they are open and closed in the same time. For example, if you use some license, for example, no derivative license, you can use the public data, or public code. But if you make some modification, if you transform the code, for example, to improve or maybe to correct a bug, I don't know, or if you want to improve the data, or you change the data, it's not possible to distribute them because it's a no derivative license. And this may be also a problem. Even if it's open, it can be open but forbidden to derivative to derive some other open database or code.
Okay, thank you. More comments about this?
I could add on to Gerard's comment. It's a very good one. I believe one of the other questions had to do with a recommendation for software licensing to try to, as a best practice, to try to avoid that situation. And they were, our anonymous person was suggesting the GPL version 3, which does require derivative products to be open. That's a very good suggestion. When we provide links to the resources, there are a couple websites that describe software licensing and those sorts of choices, and we can make that available for everyone to review. So that's, yep.
Okay, it's important. Janet, do you have any comment about this?
No. Just as the other ones. I was just checking the third question, but please go ahead. Not comment on this one.
Okay. Well, we have the second one, two. I think it's the last question. What are special advices in your speaks? You say someone, but the question is, what are special advices to enable reproducibility in deep learning experiments? Are restrictions? Someone would like to speak about this?
Yes, maybe I can talk on this one. Deep learning, as we have been working on, it's if someone could correct myself, but it's the one of the research area that is growing so fast. And also the community, I see that the community in computer science is very organized in this aspect. They are making huge efforts to make all the software that they publish, to make them more available as they can, and also using benchmarks, as well as also Laura commented about the papers with code site, which is also a great tool for starting on deep learning, also to make comparisons. And I think that some special advices is to take care about the parameters and the hyperparameters of their models on the architectures they publish. If possible, we could also access to the supplemental material where it's available the hyperparameters or any other setup that is being configured so that anyone can reproduce their papers. As well, also the configuration is one important thing, because I saw some papers from Google colleagues, I mean from Google authors, that they publish the experiments by using GPUs that are impossible to any other research to also make this kind of experiments. So that's also an issue from anybody to reproduce any kind of paper. So they also could annotate it on their documentation that the time consuming or what the requirements, the computer requirements for making available.
Okay, thank you.
Thank you.
Okay, all speaks were very useful Very good. So we are at the end of the time. So I would like if you would like to say some final words about this meeting, about the reproducibility. Sheila, David.
Well, certainly an open invitation for everyone participating to watch for the next opportunity for a workshop. Any questions you might have, to direct them to the organizers so that we could take that into consideration for programming. And a very big thank you to the organizers of the roundtable. This has been a very exciting opportunity.
Yeah, I would like to do a comment for the end. Reproducibility is something really interesting, but when you plan a project, you really have to plan in advance that you will have to take a lot of time in order to be able to give your reproducibility, to put it on a website, to put the documentation, to work on the documentation, to do some publication. And sometimes you even have to recruit some people in order, for example, for the engineering problem, like designing a website and so on. So it costs a lot. It costs a lot even for the researcher, for writing nice code and I don't know, doing a documentation and so on. So it's not so easy, and I think we have all of us to build some project and to integrate this time and those resources when we are building some project. But sometimes it's not possible, but I mean, we have to do it if we can.
May I add something about this? The cost and the effort that have to be made for productivity. I think that there are some advanced reflections in the Research Data Alliance about the virtual research environment on a kind of canonical virtual research environment that permit for researchers to avoid a big part of the effort just to keep automatically the maximum of the informations. And I think that the most difficulty will be to adopt this kind of environment at a general, global scale. But the result, and I think the gain, will be to be reproducible without thinking that we have to take that in account.
Okay. Okay, someone would like to speak. Pedro, I don't know if the photo that we said were taken or not.
Yes. So just before we finish our roundtable, I would like to everyone to say hello. If you please open your camera, just to, yes, thank you so much. Just to take a picture, smile. Yes, thank you so much. So we are going to finish our roundtable. I think we'll have a very productive time here, learning a lot. And I think this subject is very important for academic point of view and for the business, because business want to have trustable models. When you create computer models, you need to be trustable. And one requirement to be trustable that this model could be reproducibility. How much this model could be reproducibility for a data scientist, for example. I think this is the one next step that the business will take care about the models. in the data science subject, it is very, very important to have some procedures, to have some guides, and to have some advices related with this, to guide some professionals that work in this area, just to add some topics related with the business area. I think this is very important too. So I think we are going to finish our section. Please, always speakers have some, you'd like to add some comments, please, you have more time just to add some comments. Ali, would you like to talk something? Ali,
No,
Mark.
no. Thank you for this organization.
Thank you. Mark?
Oh, it's okay for me. It's okay. Thank you, Pedro. Thank you for everyone.
Thank you so much. Gerard?
Yes, I would say that as we work in deep learning, reproducibility is a key point because we have the problem of reproducibility in data and in code. Because in fact, the code, the results of the code is based on the data. So we have a mixture of big data and also very complex code. And so this is a key point for deep learning. So we are going to work with you and to discuss and to collaborate on this point. And thank you very much for this meeting.
Thank you, Gerard. And Laurie?
I couldn't agree more. So I thank you again for organizing this session, and I'm looking forward to collaborating on these topics. Thank you.
Thank you, Laurie. Romain?
Oh, I agree. I fully agree with the other presenters. We need to continue to collaborate, and perhaps more in the way of radical collaboration that permit to reach a consensus and to have tools that are recognized at the large scale. So happy to be here, and thank you for the organization.
Thank you, Romain. Jeanette, please.
Yeah, and to thank the organization to take this invitation. And I was resembling on my head about what Shelley says is that we can do the best that we can so that we can make better. I think that's the main output from this meeting. Thank you, everyone.
Thank you, Jeanette. And Alison? Sorry, Shelley, please.
Alison would love to know that Alison's our co-PI along with Dave Muyo and Nicholas Mcnutt, who cannot be here. So thank you to the 4 PIs for Parsec, the project that brings you all of these experts. We will take a lot of the comments back and a lot of the questions and build those into the materials for Parsec to push back out. And you'll see that in the next workshop that Professor Pedro organizes. And this has been such a great experience. Thank you, everyone.
So thank you all. Thank you all attendees. This is very important to have more people to thinking about this subject. And please feel free to contact every speaker. You have information about them in the website of this event. And you are going to send you email with the website with all presentations there, published there. And the video that we are recording, this section here, this around the table, will be available in the website of the event. We are going to send you in the next days, okay? So thank you all so much. Thank you, the speakers. You are very, very nice presentations. And we hope everyone will be attend in the next meetings in the Brazil. You have a next meeting of Parsec project that will happen In the next year, September of the next year, you have call for papers, call for posters. So please, if you want to submit your any subjects related with data science, related with the socioeconomic impact factors, or using deep learning, please feel free to submit your paper, your poster for this event. This is not just for academic, for business too. You can submit your papers or posters. It's very easy. You are going to publish next, maybe you're going to publish this call for papers, maybe next 2 or 3 months, okay? So thank you all. Thank you speakers, thank you all attendees. I hope to see you soon. Take care. Thank you so much.